All right, so hey everyone, I'm Jason Mizell, and I'm here to talk to you guys about version control, but mostly Mercurial. So who am I? Like I said, I'm Jason. I worked at DigiPen on the Y-front, Nous, and I'm currently working on Perspective. I also worked with the Sean's on a WebGL game called Sonar. And you could call me a version control enthusiast, I guess. That's not really a self-proclaimed title, but basically what happened was I started using Mercurial about a year ago at the start of both Sonar and Perspective, and I kind of just realized its power. I realized how much you could use it to work better, and so I learned how to use it well. And I'm far from an expert, so don't think that I'm like the de facto source on how to use Mercurial. Basically, I just ended up being in my group of people at DigiPen, the person that everyone kind of went to, and so I've just kind of taken up that role. So this is a completely untested presentation. I haven't done it before. If you're confused at all, or at least I haven't done it for an audience, if you're confused at all, let me know, raise your hand, and I'll don't worry about really interrupting the flow of the presentation because it doesn't really have one. And this is for your benefit, so don't be afraid to really press me on any of this, and I'll answer the best I can. So what is the presentation? It should answer what is version control, what should you, or why should you use version control, how do you use Mercurial, and how do you use Mercurial correctly? So kind of the best ways, or the best practices of how to use Mercurial. And those two parts are going to kind of go hand in hand. I'm going to kind of explain a feature and then explain how to use the feature in a way that will actually be helpful. So what is version control? It's also known as revision control or version control, source control. And it's essentially a system for tracking the history of data. You can look at it as just like a list of revisions or versions of the contents of a folder. So anytime you, so essentially you just check in the current version of the folder, and now you have this list of all of the versions that the folder has ever had. The obvious reasons for using this are it allows for synchronization between multiple computers. So if you're on a team, that's why most people at DigiPen end up first using Subversion. It's a really simple way to just get up and running and be able to communicate between team members. It allows you to access every old version of your files, which is useful so you can go back in time. It also keeps an external backup of your files, assuming you're using a server or hosting service, which there's no reason not to. Who here has actually heard of Project Zomboid? Anyone? Yes, one person. Okay, so basically this is an independent game project that was funded, and they actually, their laptops got stolen. And so they're like, oh man, we just lost 3 months of work. And it's like, this is supposed to be a professional project, and you don't have any backups. That makes no sense, especially when there's so many free ways to do it. And so essentially it's just kind of a professional thing. You should always have backups of your data. Losing your laptop should be a hassle, but it shouldn't be a project stopper. So why bother? Who here has seen something like this? Right. I like to call this artist version control. This is, it's not exclusive to artists either. I used to do this even for code, and it's just kind of a natural way of, oh well, I have this file system and I want to have backups of everything that I've done, and so I'll just keep adding onto it and add final onto it. Oh wait, I changed it. Okay, this one's really final, and it just kind of gets out of control. And this isn't really that useful, but what ends up happening, just to show how ingrained this is into the way people work, this is 3D Studio Max, and next to the save button there's actually a plus, so you can append the next number onto the file name, and it'll just keep going up. And this is just a random screenshot I got from Google, and even in this, it's like 01_01. That information is completely meaningless, but that's how people tend to want to work. And so a version control system is a way to do this without just bastardizing your file system. And so the main reason that you would want to use version control is optimization of workflow. And there's a reason I gave this its own slide. At some point, who here is going into their sophomore year? Right. So at some point this year, assuming you're doing well, you're going to get to a point where any given programming problem, given enough time and ability to research if it's like a technology you haven't seen before, you should be able to solve it. You should be pretty soon getting to a point where programming, figuring out how to do something is no longer really a problem. It's just something you can get through at some point. But however, that can't really, you can only improve, how much time it takes to do that by just having more experience. What you can improve is how you actually go about implementing stuff, how you actually go about doing stuff, debugging, testing, all of this. Those are the things that you can improve, and it's your workflow. And so what you should be doing is you should be learning more about the tools you're using. You should be asking other people about what tools they use. You should be reading blogs. You should learn about all the other tools that are out there, and just overall see how other people are working to improve their workflow, because that's what it's really about. The point of this presentation is to show you ways that you can be a better developer. And in my opinion, a good programmer is someone who's at that level I was just saying, where given any problem they can solve it. A great programmer, or just a great developer in general, it's not exclusive to programming, is someone who can get it done fast and get it done well. And so that's kind of the next level of what you want to be going for. So that was a bit of sidebar. How do you use version control? How do you version control? You use a version control system. Examples are Subversion, Mercurial, Git, basically all the ones that you've probably heard of. Also, Dropbox and Google Docs have version control built in. When I'm making this presentation, I can go back to any old version of it and see all of my changes. And it's just, having it built into things like that just makes it so much easier, and it shows how important it is. So what should you use version control for? Everything. The mantra is, if it's not in version control, it doesn't exist. So you should be using this for your source, any Visual Studio pre-make files, the project files. You don't need to use it for anything that can be generated from what's in the version control. So like OBJ files and stuff, obviously you don't want to put that on there. But resources, any external documentation, any libraries you're using, even though they're giant, you want to be able to go to a revision and have everything you need to have it work. Anytime I'm doing homework or a project, I version control it. Task management, everything that you're doing should be version controlled, and I really mean that. Really, anything. It's low cost in both terms of time and money. Time, it doesn't really end up adding up to anything once you get into the habit of it. Obviously, there's a bit of an investment at first, but you'll get used to it. And money, it's basically free unless you're doing like a professional project, in which case the cost is really negligible. But it's super high reward. You get a complete history of your changes or your progress. Obviously, it simplifies mostly developer projects. It removes the risk of doing large refactors. So if you aren't sure something's going to work, you no longer have to worry about, oh, I might be like breaking it for everyone, or I might be losing my past progress. No, you can always go back. It can actually even help in debugging. It can help you find problems, which I'll show you later. And finally, it keeps a backup of all your work, which, like I said, being a professional. I'm serious. Even I don't use it enough. I do use it for all my assignments and projects, though. So Subversion. Who here has used Subversion? Pretty much figured. It's known as centralized version control. Other version control of this type is CVS, which is what Subversion is based off of, and Perforce. This means that the history is stored on the server. So what you have locally is just the working version. Any sort of operations that have to do with actually modifying the repository, the version control, you have to do over the network, which means that in the cons section, you have to be online to use it, and unless you have like a local server, like if you're working at Microsoft, it's not as big a deal. But if you have any sort of external server, all of your operations are going to be really slow. Or if you have a DigiPen server. But on the pro side, there's very little extra local data. You don't even notice the extra storage implications. It's super simple to use. Subversion specifically is literally just like kind of commit, and update. Those are the only real two commands you need to know. And it is great for resources because just the way that Mercurial ends up working. It's not as great for these large files, but Subversion works really well for them. But the biggest downside to Subversion is that it's really complex or even impossible to actually use your history. Who here has done anything in Subversion besides committing and maybe going back to an older version? A few of you. It's just because it's so complicated. Who here has merge conflict did over 20 times in the history of their in the last month in Subversion? All right, not as good a turnout. But anyway, it's just it doesn't end up working as well. So Mercurial was created in 2005, which is completely irrelevant. It is known as distributed version control or version control, which means that the entire repository is stored locally. Everyone has a copy of the entire repository. And so there's not really a server because you do end up using a server, but it's just another client, and all you're doing is communicating with it, just like you could communicate to anyone else's copy of the repository. And so instead of committing to the server, you commit locally. So this is if you aren't familiar with Subversion, then this won't really make sense. But instead of committing and pushing that data to the server, you commit locally, and then eventually you push all of the changes to the repository, and you can pull from the server and all you're really doing is synchronizing. So basically, it just takes away all those cons of being slow and having to be connected to the internet. You can do everything completely locally. You don't even need a server at all, which is really cool. So tortoisehg workbench is it's a single application for managing Mercurial repositories. Essentially, if you've used tortoisehg, it's completely different than that. With tortoisehg, you're kind of going into these context menus, and it's everything is complete. Every operation is a completely separate thing. In Workbench, which you can see right here, it's just one application, and it does everything that you would want to do in Mercurial. And obviously, you get this nice revision graph, and it ends up being really useful to have it all in one place. If you're using Git, which is a great version control system as well, there's a program called Git Extensions, which is very similar to Tortoise Workbench. They actually just came out with GitHub for Windows, which looks cool, but I have no idea how good it is. But the fact that you can see this graph and just visually see everything that you're working with makes it much easier, and you end up using Mercurial way better than if you're just using the command line. And everyone I've seen who just uses the command line for Mercurial ends up using it in a way that I would consider wrong. None of these they don't follow any of the kind of best practices that I'm going to talk about. There are other GUIs, and most hosting services, including Bitbucket and GitHub, have a web interface. But I would recommend either using Workbench if you're on Windows, and there's a OS X client that I've heard is really good as well. So bitbucketorg, just kind of getting all this out of the way to begin with. So bitbucketorg is a hosting service for Mercurial, and they do Git as well. But it's kind of amazing. All repositories are unlimited storage and bandwidth, and you get an unlimited number of repositories for free. The only limitation that you get at all is that any given repository can only have up to 5 people accessing it, which obviously is good enough for most DigiPen games, but even if it's not, you can either pay for it, but it's also free for students to get unlimited users. So all you have to do is essentially email them with your digipen.edu address, and they'll unlock your repository. Also, open source projects are free as well. So finally, HGnetcom is a tutorial site. I kind of use it as a reference for some of the slides in this presentation. It's a good read, regardless. So if you're unclear with anything in this presentation, you can talk to me, you can talk to other people. You can also read this site. And the first chapter, it's kind of laid out like a book. And the first chapter is subversion re-education. So it literally says, if you are coming here from using subversion, read this chapter. Otherwise, skip to chapter 2. It's because Mercurial works in a fundamentally different way, and the way that you have to use it is fundamentally different. And so most people coming from subversion end up using it like subversion, and that's the wrong way to do it. And the main reasons for this are, in subversion, you commit code, and that means that everyone else sees it. So whenever you commit something, you are essentially saying that it has to work, otherwise you're screwing everyone else up. In Mercurial, you commit code and no one sees it until you push. And even once you push, if you're using it according to the good practices that I'm going to talk about, it still won't affect them until it's in what we call the default branch. But essentially, since everything is local, it means that you no longer are ever in danger of completely screwing up everyone else until you actually push, which is amazing on its own because you're no longer blocking other people just by working. In Subversion, history is a list of revisions, and so it's like this just linear set of changes of versions. And so basically all you can do with that is move between them because that's all the data you really have. Technically it doesn't store it like this, but the way that Subversion looks at it and the way that you look at it is just all of the different versions that this file had, or that each file had. With Mercurial, history is a graph of change sets. So is everyone familiar with a graph that's kind of a 280 kind of thing? So basically a graph, instead of being a linear list, it means that each node can be connected to any number of other nodes. So it's just kind of this interconnected web of nodes. That might sound complicated, but it ends up being really simple. But the other big change is that they're change sets, not revisions. And so by change set, they literally mean set of changes. So each node contains all of the differences since the last version. So this means that you can not only move between them, but you can also undo a change. You could apply a change to another branch. You can just do a lot more with it because it has that extra information. It also means that merging works way better because with Subversion, it's essentially just taking these two unrelated files and trying to see how it can mix them. With Mercurial, it sees how from where the files were the same file, and it sees how they've both changed, and so it's able to merge them a lot more elegantly, so you don't really conflict nearly as much. All right, so let's actually get to it. So to create a repository, locally you can run the command HGnetcom. I kind of mentioned the commands in here, but I'm going to show you how to do everything through Workbench. So let's say I have this file in here or a folder in here that I want version controlled. So folder. Literally all I have to do is new repository, destination, this folder, and there can even already be a file in here. So file, and there's stuff in it. So all I have to do is put it in here, and you can see here that the command that's running, because all this is doing is running these command line commands. I hit create, and we're done. We have a repository. And you can see that all it did is it added this .hg file, and as well as a .hgignore file, which I'll talk about later. But that's the only difference between a regular folder and one that's in a Mercurial repository is this .hg folder. You can even look at Bitbucket as just a folder with .hg on it, and in fact, if I put this in a web host, I could push and pull from it just like from Bitbucket. It's literally just a folder. However, that's not really that useful because I'm not connected to anything online. And so the easiest way I could connect this repository to be online, but the easiest way is to just create a repository on Bitbucket and then clone it. And so if you go to bitbucket.org, it's very important that you go to .org and not .com. I can literally just say, create repository and say like demo. I say that it's Mercurial, and you could select the language if you want, and then you hit create. And that's it. And right here, I can see the URL of my repository. And literally that's it. I have a repository. I can go back to Tortoise, hit clone, file clone. And for source, I give it that URL that's right here. And destination, let's say I want it to be like demo. So I hit clone, it runs, and now I have a clone of this. And so now if I'll show committing files in a bit. But so now I have a clone of this, and by clone, it's literally just a complete copy of the entire repository. All right, so
I have a question.
Yep.
That initial folder that you created and created the repository from, those files with that extra file you added, where are those? What are those doing now? Didn't you create a different folder to be the local repository?
Sorry, could you rephrase that?
The first.
The folder. Yeah.
That one. How is that connected to your local repository, or is that?
So this is a completely separate one, and you can even see here. This is like just a list of repositories in Workbench, and so this is one repository, and then this is a completely separate repository. I actually could communicate, synchronize between them, but I'm not going to do that. So yeah, this one is just a this demo one is just a clone of the Bitbucket hosted one. All right. Also, you can import, if you go to repositories, import repository, you can actually even import a subversion repository, which is really cool. I haven't actually tried that, but it's something that they say they support. So, all right. So I had extra space, so I put a puppy. So adding, removing files. I kind of lied before. So in this folder repository, this file actually isn't in the repository yet. It's in that folder, and so it's in the working directory. But it's not actually in the repository. To put it in the repository, so just so I can work in demo, I'm going to show that, let's say like file, and then there's stuff in it. I actually have to do a command HGadd, and then of course there's HGremove, which is the opposite. And so that will change, or that will tell Mercurial that on the next commit, which I'll go into in a sec, I want this file added. And so I want essentially almost every operation in Mercurial, you're setting up the next change set, and then you commit that change set to the repository. And so if I select the working directory here, if I select the working directory here, I don't know why it's overlapping. You can see that there's this file.txt in there, and it has a question mark, which means that it's not in the repository right now, and so it's not tracked, so it's unknown. To add it, you can either right-click, hit add. You can also just check this box, and that will set it up to be added in the next commit. Sometimes either this view right here or this view won't be updated. Workbench actually is kind of a buggy program. The reason it's great is because of the user interface, not because of the stability. But if you just hit refresh, it updates all of its data and all of the views. So I would just get in the habit of hitting this refresh button or this refresh button as often as possible. So anyway, now I have this set up to be added, or I can even hit add, and now you can see that the status is A and it's green, which means that it's going to be added in the next commit. So committing, it's literally the command hgcommit, and what that does is it takes all the changes that you have set up since the last change set and creates a new change set. And it requires a commit message. This is I'm just kind of doing things arbitrarily, so I'm just going to say commit or added file.txt, and then you just hit commit, and now you can see that it added this node to the graph that the working directory is coming off of. This circle around the smaller circle means that that's the one that the working directory is coming off of as well, and that's it. It's added to the repository, or committed. So when it comes to commit messages, this is kind of the more best practices thing. It should be as descriptive as possible of what the change set does. So most of the commits in my repositories end up being kind of bad, actually, just because I'm lazy. But as I've been using Mercurial, I've been getting better. But just for reference, if you see a commit message like minor changes, that's actually bad. Like, that's not enough information for you to be able to look at that commit and be like, I know what it's supposed to accomplish. You could say something like modified game object factory to be more readable, and that would be good, because now you're saying what was modified and why it was modified, and why it was modified is really important. But what would be the best, an even better commit message would be modified game object factories initializes component enumerator loop to use for each for readability. It's long, but I mean, it seriously doesn't take that long to write something like that. And now you can see what was modified very specifically, not just the class, not just the function, but what part of the function. You can see what it was modified to, so because now it's using for each, so now you can see what, not just what changed, but how it changed, and it still says for readability, so you know why it changed. So that's a really good commit message. Like I said, even I'm lazy, but you do get better as time goes on, and just make an effort.
Let's say you have a file and you change it, and then you forgot all the changes you made. Is there a way to kind of like see the differences?
Yes, and I will show that in a little bit. Yeah, and there's also, I thought I had something. If remind me later if I don't cover that, because I'm pretty sure I have a slide on it. All right, so there's kind of a pitfall here when it comes to if you rename a file or if you move it. Essentially, if you rename it or move a file, all Mercurial sees when it scans the directory is, and I can actually just show you. So let's say I rename this to another file, .txt. So now when I refresh this directory, you can see that it has this exclamation point. That means that the file is missing. And if you see the question mark, obviously it says it's not tracked. So now it thinks that you added a file and removed a different file. The problem with this is that now you've lost this connectivity. So you actually can go into files and see like file history. And so obviously there's no other commits. But if I were to commit what's here right now, it wouldn't see the connection between those files. It would see them as two discrete files. So what you want to do is you want to do what they call detect renames. You right-click the files, so I can just like Control-A, select all of them, right-click detect renames. And so what this will do is find all of the things that are that it thinks are moved files or renamed files, and then instead of running the add and remove methods, it'll run the move HG method, which is just another command. And so if I just hit find renames, it sees, hey, look, file and another file are 100% match. And so accept selected matches. And it still says add and remove, which is kind of silly. But if you select this the one that's being added, you can see here it says renamed from file.txt. So you know that it's going to preserve those, that connection. And so now if I commit this, so renamed file.txt to another file.txt, you can see that now I can look at this file history and it still is connected to that the earlier version of the file, even though it's a different name. So anytime you do any sort of refactoring, make sure you do that. Actually, our tech director didn't know about that when he completely redid our folder structure. And so in our repository, at about revision 1900 is basically where every file in the repository goes back to, and that's the first commit you can see of any given file, which means that those 1900 commits before it are no longer connected to the commits after it, which is terrible. All right, so HGignore. This is a file that just specifies what in the folder not to commit, which is really cool. There's actually no HGignore file in here right now because Bitbucket didn't set that up. So let's just do that. So the easiest way to do anything with HGignore is to use workbench, obviously. So I'm just going to say, like, let's say I have this file, file I don't want, blah, .txt, and there's an apostrophe in that file name that really is freaking me out. So if so you can see that obviously, it has that question mark. If you right-click a file like that, you can see this ignore command. And what that'll do is that'll modify the HGignore file, and it'll modify it, or it'll create it now if it doesn't already exist. And so you can just select files that, has created, yep. And so I literally just added it to that, to the HGignore file, close, and now you can see that it no longer tries to see those files. It no longer sees that file I don't want in this view. So it's no longer going to try to add it. And if you look at this HGignore file, this is just a text editor. I highly suggest you look into Sublime Text 2 if you haven't already. Sorry, that's the wrong file. If I look at that .HGignore file, ignoring this first line, it's literally just a list of files you don't want, and it supports wildcards, and it actually supports multiple wildcards. So if I don't want to see any .txt files, I can just do that, and you can do the same thing in that editor. And so now if I refresh, it still doesn't see it, even though it's star.txt. You can even do like star/bin/star, anything like that. You will notice that it still has that file.txt in the repository, even if I committed this star.txt. HGignore only applies to files that are in the working directory that aren't yet in the repository.
Is there a wildcard that can maybe go from the directory and go down?
Yeah.
For everyone for that file?
Oh, Yeah, so this wildcard will, since, essentially you can look at it as just like the string. So if it's like bin/whatever/whatever, all of that is still covered by the wildcard. So anything in the entire repository.txt will be ignored. So if you only want it to ignore in specific directories, you have to set that up. Yep.
So if you wanted to ignore everything in every subdirectory, just one wildcard would do it?
Yeah,
Okay.
I believe so anyway. Sean is shaking his head yes, so I think that's correct. However, now it's still adding this HGignore file, even though I got rid of that, but now it sees this. If you actually don't want that file in your folder at all, I probably should mention, the reason to use something like HGignore is for like, if all the files that you're generating that you don't want in the repository, so things like exes or .obj files, all that kind of stuff that's just kind of extraneous and that you don't want to pollute your repository with because you don't need to send it to anyone and you don't need to have a history of it, or you don't want to have a history of it, that's what you would use HGignore for. If you want to actually get rid of them, you can right-click delete unversioned, and it'll let you just delete it inside. You can also obviously manually delete it. So created.hgignore. All right, so let's say I want to go back. I want to go back to when it was just file.txt, because another file.txt is really long and I don't like it. So what you can do is you can go back using the update command. This updates the working directory to another change set, which is a really confusing name. I kind of just think of it as go-to. So you're going to that revision or change set. So if I just right-click any change set, hit update, now you can see that the working directory is connected, is coming off of this revision 0. And you can also see that now this is actually a graph, not just a list, because these two are branching off it in a completely different way. And finally, I'm just going back to the revision 2. Finally, like I said, everything is local, and so the only way to affect the remote repository is to push. So right now, if I go back to here, it still thinks I haven't added anything to the repository, and that's because Bitbucket hasn't seen any of the things that I've just done. And so what push does is it sends all the change sets that the remote repository doesn't have to it. So it does a check to see what it has and what you have, and then sends all the change sets that it doesn't. Remember that there is technically no server. There are only other repositories, and Bitbucket is just the repository that everyone is synchronizing with. So it's just the one central location that everyone is synchronizing with. It's not the location that everyone is actually doing commands on. And then pool is a related operation that will get all of the change sets that your local repository doesn't have. So obviously you don't want to push you don't want to push your change sets if you don't have Bitbucket's change sets yet. So it's always good practice to pull, then deal with anything you need to, then push. And we'll talk about that a little later probably. So to push, you use these two buttons. This button is pull from the selected URL, and this is push to the selected URL. And by selected URL, there are these 5 buttons right here. These are the different views. And so if you go into a synchronized view, then it shows my list of, this is actually a list of all of the repositories that I've ever synced with this, and I can add ones. I can just like type one in like this. I can also do the HTTP or HTTPS. And when it's HTTPS, this is something that a lot of people kind of miss. If you select this, you can actually hit this button right here, and that'll let you save your username and password, which is really nice. And then if you want to save that, you can hit this button and save it, remove authentication data, and then default already exists. Default is the one that you'll push and pull from if you don't have anything else selected. And I already have my password in there because it's the same Bitbucket account that I always use. So if I push now, remove all, yes, and then save the path. So you can see down here in the output log, it's saying what it's doing. It added the 3 change sets with 3 changes to 3 files. Hey, so if I go back here and refresh, you can see now Bitbucket has all of those change sets. And obviously no one else is using this repository, which means I don't actually have to pull, which is nice. So now on to the more fun stuff, unnamed branches. So a branch, like I said before, is a linear chain of change sets. So Subversion only has one branch. Technically it supports branching, but it's kind of more forking and it's just terrible. Who here has used Subversion branching? You guys are insane. So if 2 commits are coming from the same change sets, they are each in an unnamed branch, which is a terrible name, but whatever. So you can see right here, here's the first change set, and here is a second change set, but here's a different second change set. So these are each in an unnamed branch. You can see they're both, or I'll talk about that in a sec. But this also means that if someone is working at the same time as you, and then they commit to the or push to the server, and when you pull that, you're going to see because they started working from an earlier commit than you did, or from the same commit you did, you're going to have these 2 unnamed branches. And obviously, like I said, like when I go down here, I can just update to an earlier revision. I could commit now, and I would just be in an unnamed branch. So merging is usually as simple as running HGmerge. And what this does is it applies, so you essentially merge with another change set, and it'll apply all the change sets from the other branch since they diverged onto the working directory. Since it affects the working directory, you also have to commit the merge as its own change set. And if it can't figure out how to do this, that means that there's a merge conflict, and we'll deal with that a little bit later. But let's just say right here, let's say I added another file from back from revision 0. So here's like a completely different file stuff. And so I just check that, added a completely different file. Add. And so now I'm in this unnamed branch. So the way that I would merge both of these into this one is by selecting the head, which is essentially the most recent commit in, or the end of an unnamed branch. And so I select the head. I could select this one and then just merge it like that, but there's no reason to do that in this scenario. So I would right click and then merge with local. And as you would see, that means that you're going to merge those changes from the branch you selected into your working directory. And so this is just all of the data of what you're doing. You hit next, and no merge conflicts, ready to commit. Hey, Subversion would totally merge conflict on that. And then the commit message by default is just merge. This is the one scenario in which a short commit message is completely acceptable. Because you're just merging unnamed branches together. You don't really need any more information than that. So just hit commit, and it automatically commits for me. And so now you can see the 2 commits came back together into this one change set. Is that all clear? All right, good. So named branches. You probably noticed that there's this branch thing right here. And it says default, and it also says default right here, which is kind of weird. Tip is just the most recent commit, and it's not really that important. But this list of default is really important because because default is a named branch, and essentially the only difference between a named branch and a unnamed branch is that a named branch can only be pushed, so you can only push everything that's here if there's only one head. And so there's only one head here, which means that I can push it. But if I did another unnamed, so essentially you can only push if there's only one unnamed branch in each named branch. Like I said, the name scheme kind of makes it confusing, but it's pretty simple once you see it. But essentially what this means is that to push, you either need to merge all the named branches in the unnamed branches in the named branch, or you create a new named branch. And so to do that, all you have to do is before you commit, and you can actually just commit making a new name branch, in the commit window, which is this one, you hit branch, you click it, and then right now there's no branch changes. You can hit open a new named branch, and so like my named branch. You can also close the current branch, which closes the current named branch. You can't close an unnamed branch. Well, you can, but it'll just not do what you expect. But closing a named branch, it doesn't actually effectively do anything except for tell the repository that the branch is no longer being used. And so if you want to like query for all open branches, you won't get a list that's 1,000 branches long. You only get the ones that are actually being modified right now. And so I can like open a new named branch. Let's just say like new named branch opened. And then when you do that, it will ask you like, are you sure you want to do that? And then yep. And so now you can see that the graph is a different color, or the node is a different color, and it's the same color as this. And you'll also notice there's this green box around my named branch, just like there is on default here. And what that shows is that that green box with the name of the branch in it is indicative of that change set being the head of the branch. And so if you have multiple heads, you'll see two with the same name. So does that make sense with everyone? The concept of named branches? All right, so default branch isn't really special at all, but it ends up, just because obviously it's the default, it ends up being the branch that everyone is synchronizing with. And so it doesn't necessarily have to be your stable branch, the idea of having a branch that is always 100% working and has nothing at all experimental in it, which is something that you might want to have, a stable branch. But it's the branch that everyone else is going to be using. So the way that you want to look at it is that you should always be working in a named branch, and you should merge default into that named branch from time to time, just to stay updated. And since people are going to be doing this, that means that nothing should be pushed to or merged with default or into default. Nothing should be merged into default unless you're okay with everyone else on the team getting it. So default branch is the branch that actually affects other people, and other people will be synchronized with. And then once you're finished, a feature to the point where you're comfortable with other people having it in their code, you close the branch and merge it into default. So that's the correct way to use named branches. I like to, well, I've never really called it before the presentation, but a good way of putting it is that it's a sandbox. So a named branch is a sandbox that you can work in, and you should let me start over. The approach that you should take is that you should never prevent someone from working just because you're working. So at the same time, you should be constantly committing change sets. Like most people are used to subversion, so they essentially work and then they commit everything at once they're done. And that's just terrible because you no longer have that history. You want to be committing constantly, and I'll talk about that more in a sec. But at the same time, you don't want to prevent other people from working. So you have these two conflicting things where you want to be able to commit things that don't work, but you don't want them to affect other people. And so you should always work in a named branch and then only use default for synchronizing. That makes sense, right? Yeah. So when I say constantly, I really mean constantly. Each change set should be representative of one change. The smallest unit of change you can think of, that's what a change set should be. I tend to commit every 5 or 10 minutes, sometimes every minute, sometimes even less. I'll commit a bunch of things just one after another when they're really small changes. Because committing, the only cost of doing it is writing commit message. Unless you're working on a team with, over a dozen people, I would say, maybe even more. Unless you're working with a really large team where a lot of people are sharing the same repository, having a longer list of change sets that you have to look through isn't a big deal at all. It doesn't really negatively affect you unless you have 100 people working on the team. So the only cost is writing that commit message. And if you do a lot without committing, you can even commit in pieces. And so I can show you that real quick. So let's say I modify both of these files. So now other stuff. And I also something sensitive. So I just changed both of these files, but those are two completely different changes. But you'll see that by default, both of these are checked. You can actually uncheck it. And so as long as your changes, this doesn't always happen, but as long as your changes are separable by the files that you worked on them in, you can actually separate them and then commit them separately. So like changed another file and changed a completely different file. And so now they're in two commits, which is nice. But really, commit constantly. The reason that you want to commit in such like small pieces is it allows for a more iterative history of your timeline. So you can, that sentence made no sense, but it makes your entire history more iterative. So you can see all the changes and just read them off to see what someone did through the course of their working. It also kind of documents your work, being able to just, you can, I'll show later that you can like go into any given line and see what or how that was modified. And so you can actually just see why everything was written just by looking through your history. It also helps you isolate problem code using something called HGbisect. I'm going to talk about all these later. You can remove individual changes using HGbackout, and you can apply individual changes to other branches using HGtransplant. And so just having all of these separated instead of one giant commit that is rote graphics just allows you to do so much more. And of course, it causes problems with nothing. If you're using the sandbox approach that I was talking about later, commits will never bother anyone. And if you're afraid of other people seeing your workflow, then you have a much bigger problem. When I tell people to do this, the most common response is, oh, well then someone else will, or everyone else is seeing everything that I'm doing. And if that's a problem, even if you're at a company that, if they see you made a mistake or something like that through the course of working, as long as you are aware of it and you fixed it, why is that a problem? People make mistakes, especially at DigiPen where everyone is learning. You should, when you're on a team, you shouldn't be like looking at other people and judging them based on the mistakes they made, as long as they're fixing it and doing things correctly from then on. So there's really no problem with just having everything that you're doing be committed and documented through your Mercurial. So this slide isn't really how to use Mercurial, it's how not to. I've seen people relatively often actually try to use multiple copies of the same repository in parallel. So they have two clones in different folders of the same repository, and then they're using them at the same time. This comes from SVN because that's the only way to do certain things in SVN. If you want to work on two things at once, that's the only way to do it. But it just causes tons of problems because now you have these two things that aren't synchronized. So the only way to do, or the only time that I've ever done it, and the only time I can think to ever have two clones open on the same computer at once, is if you want to use two branches at once. And even so, you can still sync with the server and each other because you're in two different branches, so they're not going to affect each other. Named branches, usually when I say branch, I mean named branch, but you kind of just have to go with context. Essentially, and I've done this before where it's like, someone's doing a complete rewrite of one of the systems, and I'm helping with that, but at the same time I'm working in the normal branch too that is actually working, and so I want to be able to switch between them and updating between the two branches since they're so different. It freaks out Visual Studio and stuff. I want to have two versions of Visual Studio open at once. That's fine as long as you're still using Mercurial correctly and you're still saying synchronize. But if you're not staying synchronized, you're doing it wrong. On that note, you could actually, there's an option that it's kind of buggy, so I don't use it, but there's even an option in HG Workbench that every time you commit, it pulls and pushes to the server. And that hypothetically should never cause any problems because you're working in your little sandboxed branches. And also, just to be clear with named branches, these are just kind of a few things I just realized I missed. you can have a named branch that multiple people are working in, but they should, whenever they're doing something, they should be in a named branch off of that named branch. So you can have like a graphics refactor named branch, and then have all of the little pieces of that graphics refactor in their own name sub-named branches.
So what is unnamed branch? Do you ever work in it?
The unnamed branch is a branch that isn't explicitly made using the make new named branch thing. So if I update back here, and like I said, sometimes it doesn't refresh. So if I committed right now, I would be creating an unnamed branch. It's inside this my named branch. So like it essentially an unnamed branch is still part of a named branch, but a named branch can only be pushed if it only has one unnamed branch. Does that make sense? Is everyone else good on that, or?
Branch only arises when two people commit from one node.
Usually, or because like I said, I can just do this manually. But that tends to be how the unnamed branches come up. But since you can't push unless they're merged together, it means that you're going to be like causing problems with other people. So working in a named branch means that you can push as much as you want, and it's not going to affect anyone else because they don't have to merge with it until you merged it into their named branch. All right, you can talk to me after if you want. So merge conflicts, fun. So obviously a merge conflict is when you do a merge and it doesn't, Mercurial doesn't know how to do it. The change sets are kind of conflicting, and so they're doing things that don't make sense to be done at the same time, and so it's asking you for help. And so in Tortoise workbench, several options appear, and so I'm going to instantiate a merge conflict, which is always a terrible idea. So I'm going to go back here. This is totally going to resolve itself. The other change set is removing this and adding something sensible to, it's removing stuff and adding other stuff, and that's in a completely different file. So I'm going to say like different stuff. So I save that and I commit it. So that's terrible, but these are arbitrary changes anyway. So now I pull and hey, Jason made this commit that I wasn't aware of. So now I have to merge it, hit next. And this is what it looks like when it's a merge conflict. You can see one file is unresolved, and so you have to click this link here. And that pops up this window, which shows all of the unresolved conflicts. And so there's several options here that, and this kind of confuses people, but it's pretty simple. For each one of these conflicts, you can select them in this list box. You can say Mercurial resolve, which it uses an algorithm to try to resolve the collisions. So on its own, though you can make this be the default behavior, it's not going to try, if it detects a collision, it's just like screw it. Obviously, this isn't simple enough for me to do. You decide what to do with it. But Mercurial just has a built-in algorithm that you can try to use. And that's I usually literally just hit these two in order. The next one is tool resolve, which will use an external tool, basically the one that's selected down here, the default being kdiff3. Basically, it will use this external program to try to resolve the conflict. These three buttons are if you want to do something more manual. So take local will just ignore the other file in the other branch and just use the local file. The local file being the one that you are at, and the other file being the one that you're merging in. Or by file I mean version. And then finally there's mark as resolved, which you can see if I actually go to this, then it's totally making a liar out of me. it'll just take whatever is currently in the working directory and be like, whatever, it's resolved. Sometimes it'll have like data in it where it'll show like both and like the revision hashes and stuff. But basically this is so if you want to just go into an editor and modify the file, you can do that and then just mark it as resolved and have it be done. So let's try Mercurial resolve. As you can see, conflicts during merge, so it didn't work. Tool resolve, we'll use kdiff3. And so this is the default merge conflict tool. And the thing that confuses people is that first it tries its own resolution algorithm. That's a little bit more powerful than Mercurial's built-in one. And so a lot of times you'll hit tool resolve and it'll just be done. Just like when you hit Mercurial resolve, it'll just do it and you won't have to do anything else. If that fails, now you have to manually resolve it using their terrible, terrible GUI. So yeah, that failed, which means that now kdiff3 opens, or the GUI opens. And it's a terrible GUI, but it will make sense once you get it explained right now. So there are these 3 columns in this row on the bottom. The first column, base, is the version of the file from before it was modified. So you have your 2 versions. This is the version that they both stemmed from. B is going to be your local version. So this is the version that you had before you tried merging it in. And C is the other version, the version that you're trying to merge in. And so what you do with this is you can select the different, this will show like all the different merge conflicts inside the entire file. And what this last thing is the output. So this is what the final version is going to look like. And so what you're going to do is you see these buttons up here. This is go to previous conflict, go to next conflict. There's only one conflict, so they're grayed out. But you're essentially going to click through these to get through all the merge conflicts, and then to actually resolve them, you hit this A, B, C button. And so if you want to use the old version, you hit A, and now it's done, and I could just hit save, and it would mark it as resolved. But let's say I want to use B, or better yet, sometimes you actually want to use both. This is pretty common if 2 people added features to like a similar function or to the same function, then you're actually going to want both of them. And so this out also does it in the order that you click them. And so now it's CB. So let's say I want that. And so I hit save and then close it. And you can see it's already moved to resolved conflicts. And once there's nothing in here and you hit close, no merge conflicts ready to commit. Hit next and it's just like a normal merge. And so now these are merged together and I can commit, or I could push. Any questions on kdiff3? Awesome. Fixing goofs. I searched for fixing goofs, and this was the first image. I have no idea what it's from, but it looks awesome. So there's a few things you can do to fix a goof, and that's a term from HGnetcom. The first is HGRevert. And so if I go back to any of these, I can right-click the, and I should mention that in this view, this is the commit view, so this is all the different things. Oh, hey, look, there's the ORIG file. So ORIG, or standing for original, is a file that will generate when it has merge conflicts. Sometimes it's really inconsistent and really annoying, but it'll sometimes generate that file just so you can see the old version. I usually just delete unversion. Sometimes it'll also make a .bad file, and I'm not exactly sure what situation it does that in, but once in a while they show up. Anyway, so if I, in this view, which is the revision details view, it'll show all of the differences. So like I select here, and it shows me the differences in that file of that change set, as well as information about the change set. So like you can open this, you can see who it was done by, what branch, the parent, the child. You can also see this, it shows the revision number, but that's going to be inconsistent between you and other people because of the fact that you're committing differently, because they're both local. But what you can use is this hash, which is a hash that will uniquely identify that change set. And I'll show you how you can use that later. The hash is actually like 3 times as long, but this is the shortened version of the hash. So anyway, you can right-click a file at any of these revisions and do revert to revision. You can also go to this view, this file, which is the manifest view, which will show you the entire repository at any given revision. So it's not just showing the files that are changed, it's also showing everything at that version. And so you can go back to any version, right click, revert to revision. And what that'll do is that'll commit it will change the file back to the version of that file at that revision. You can also do HG rollback, which is kind of shady, but it's really useful sometimes. So what HG rollback does is it undoes one commit. And by undoes, it means it's actually like, it's like hitting undo. It's just acting like it never did that. But it can only do one commit. It can never do more than that. Once you do it, you can't do it again until you do another commit. And you also can't do it if you've pushed, because if you've pushed, then it's already on another repository. It's done. And so if you commit a large file and then you push it, that file is now permanently in the repository. It kind of sucks, but that's the way it goes. And to do that, you go to repository, rollback, undo. So if I hit that now, you'll notice that it says preserving file changes. That's because it's just going to undo the commit. It's not going to undo the working or any of the actual changes. It's just going to undo the commit itself. So if I hit yes, you can see it still says that the working directory is merged. And I could recommit this, and it's as if I never hit that. But that it's just useful. And then you can also, so if I don't want this merge to go through, it's still in the working directory, but I can just update back to this and discard the changes. But I'm gonna commit this. So that's useful when you really screw up, but you catch it real fast. Finally, there's HG backout. Now, HG backout is literally going to apply the opposite of a change set. And which might sound weird, but Mercurial is, just to kind of give a little background, it's line-based. You might have noticed here, it's saying, this line was removed, this line was added. If I just kind of append to the end of a file, it's just going to remove that line and add that line. And that's how the entire thing works. Which means, but since it's so simple, it means that I can literally do the opposite. And so if I say did a back out of this, so you right-click the revision back out, it'll literally add this line and remove this line. It's the exact opposite. And this is one of the main reasons for doing that. Committing in small changes, because now I could literally just select a bunch of them, or I guess I can't select a bunch of them, but I could just go back and back out the changes one at a time and just undo the things that I don't want anymore. Just to show it, so you can understand, let's say I said something not sensible. And then I'm silly and I committed it. So let's say I pushed that, and so now it's permanently in there. So instead of going into this file and modifying it by hand, because now and now you have to document what you're doing, and it's no longer staying within the Mercurial way of thinking. So what I can do is I can right-click back out, and it doesn't have to be one that's completely previous. You can back out any changes and it'll try to do it, and if it doesn't make sense, it'll let you know. And so I hit next. And then there's default commit message. This is another situation which I think that the default commit message is fine because it's pretty self-explanatory. You're undoing that commit, and this is that hashtag again. So I hit commit, finish, and now I've backed out that commit. And so now in the working directory, you can see something sensible. You can also back out a backout, which is pretty common actually, if you backed out something you didn't want to back out, or if you want to restore something. Because that's the thing you have to understand, is that it's literally committing the opposite, which means that, let's say someone committed something to or you merged something into default and it breaks what you were working on, and you're like, oh man, I don't want that anymore. Doing a backout of that will actually remove that change. So when you merge that back into default, it's going to undo that change in the default branch. So you can still do this, but you just have to remember that you want to back out the backout before you merge in. And so you just have to make sure you think of it as you're not ignoring it temporarily, you are literally applying the opposite of it. Finally, the last way to fix goofs is merge discard, which is a terrible way to do it, but essentially what it does is it merges in a branch without applying the changes. So it's actively committing the ignoring of the files in a similar way that backout is committing the opposite. This is committing don't pay attention to these commits. And so it can be kind of hard to undo. Nothing is unfixable, but if you screw this up, it can get messy. And if you use named branches correctly, you should never have to do this, since you can just close a branch without merging it into default. Remember that named branches can just exist on their own; they don't have to ever merge into default. So if you're using named branches correctly, you shouldn't need to do this. But let's say I go back here, and let's say I don't want this at all, and this is like a huge chain of things, and I just don't want it, and I know that I will never want it. So what I can do is hit merge with local, and if you go down here to options, discard all changes from other revision. Hit next, and this is so terrible, it even warns you, like, this is stupid, why are you doing this, are you sure? You hit discard, next, commit the merge, and now it says it's merged in, but all it's doing is completely ignoring this. I usually, in the commit message, also write like merge discarding other branch or something like that. So this is something that you shouldn't need to do, but it's something you need to be aware of so that you can fix major disasters. And we're done. So basically you just really need to use Mercurial. If you follow these guidelines, you should start to see why it's so powerful and why it's going to make you a better developer just by using it and using it well. Even though we've made some really major mistakes, in Mercurial, like I said, our history kind of got cut off halfway through the project, or more than halfway through the project. But we haven't had any problems nearly as big as we did in Naus, which used SVN. And so Mercurial is just a tool to save you time, so invest early to get the most out of it. Or are we done? All right, so if you're crazy bored, you can leave now, but it's time for things that I think are really helpful in terms of using Mercurial. All right, so the first thing is VS Commands Lite. It does a whole lot of things. It's a plugin for Visual Studio, as you would expect. And it does a whole bunch of stuff that I don't really use because I just don't find them that useful. But it does do one thing that is really useful in terms of Mercurial, which is reload all projects. So if you have a lot of projects, which you probably will once you've seen Jeff's lecture next week, and so if you have a bunch of projects, when Mercurial changes a bunch of stuff, so if let's say you update to an earlier revision that didn't have all the same files or something, Visual Studio is going to be like, oh no, you want me to reload this project? And you do, because it's otherwise it's using this old version of the project. And what will happen is it'll do this for all of the projects. So in Perspective, we have something like 10 or 20 projects, which I recommend. It's actually really useful to do that. But it meant that anytime I would change I would update to an older revision, I would have to click reload project about 20 times. And sometimes it would crash, and Visual Studio just doesn't know how to handle this. And so all this does is if it detects any projects are modified, it will let you reload all of the projects at once. And so it's useful and it's free for the Lite version. The only fallback or problem is that it has this GoPro thing in the corner and so it doesn't like add pop-ups or anything like that. Another thing, this you should probably just have regardless of what version control you're using. In Visual Studio, if you go to Options, Documents, you want to check Detect when file is changed outside the environment and Auto Load changes. And it actually works really well. Even Sublime doesn't do it as well as Visual Studio does, because it'll keep the text files in the editor at the same line that it is. It'll just change in place, which is awesome, and it's just really useful. So, and yeah, auto load, because otherwise it'll ask you if you want to, and you're going to be doing that all the time, so it's really annoying. Okay, so more HG specific stuff. Transplant. HG transplant is actually an extension, but it's a really simple one, and it's totally worth using. So if you go to settings, and just in global settings, if you go to extensions, here are all the extensions that are actually built into Tortoise Workbench. You can download other extensions and kind of put them into your build weirdly, but these are the ones that are built into the GUI. And so you can see I have like churn is kind of useful, rebase is really useful, but it also can break things horribly, so I'm not going to show that now. But transplant is pretty simple, and all you do is you check the ones that you want, and then when you close this, it'll usually ask you to restart Workbench, and that's about it. So what transplant does is it copies a change set from one branch to another. So essentially, if I'm, back in default, so I'm in default here, and let's say I want this just this change set. Someone made a fix in a branch that's 20 branches away, and it's a universal fix, and I want just that. Instead of just modifying it and manually putting in that fix, because that's silly, you can just get that one fix, and once again you have your kind of separable change sets, so you can do that. All you do to do it is you right click the change set, transplant to local. And then I'm going to undo it because it didn't know how to do that, because it didn't really make sense in context. So I'm just gonna okay, so change another file. Okay, so let's say I want this one. I do transplant to local, and now literally it copied, changed another file to the default branch. And when you merge those together, they won't break, or it won't like try to add it twice. It's aware that they're the same thing, and so it won't do it again. And so basically, this is useful when, like I said, when someone in another branch needs an independent fix from a different branch. All right, bisect. This one's really cool. So let's say that at some point, so you're working, you're in crunch mode, and then you realized at some point in the past 2 weeks a feature broke, and you didn't realize it until now. And it's not something because you haven't touched anything even near it in the past 2 weeks, or in the past week or something. I've actually done this manually, bisecting. So essentially, because you have this list of, or you have this graph of history, the obvious way to figure out what broke the Berkta bird is to just do a binary search between the history, or through the history, and figure out which commit did it. And all bisect does is exactly that, the binary search. So let's say, let's go back here, and let's say I know that at some point between here and here, something broke, something broke, and I'm trying to figure out where. And so what you do is you select both of them, so control click, and then you right click, and it's kind of confusing, but it's the order of which one to do is the order of the first one you clicked and then the second one you clicked. And so in this case, I know that the first one I clicked was good, the second one I clicked is bad. I hit that, and it even confirms it here. The last known good revision is 2, the last known bad revision is 10. And so you have this problem. What you want to do is you want to go back really far enough that you know that it's working, test if it's working just to be sure, and then select these 2 revisions. And so now you can see that in here, I can't select in there. So what it did is you can see that it went between the 2, it literally went to the exact middle of history between those 2. And the cool thing about this is it's aware of branches, so it'll actually do it correctly. You don't have to like manually figure it out. And all you do is it automatically updated to that. And so now I test it, and then I say whether or not this one was good or bad. And so let's say I know this one was good, I know this one was good, and then I test it, and this one was bad, and it says culprit found. I now know that it was Jason, and it was in the branch, good, he didn't give me a good commit message, so he has no reason for having to commit this. It automatically it stays at that commit. So now I know that this is the exact change that broke it. Once again, the separable change sets means that you know exactly what line, you know exactly what change broke the build. So that's really useful, and it means that you know who to punch when a bug happens. All right, so next, it's just a simple feature, the filter toolbar. So if you hit Control S in any of these views, just because it's part of this, the repository view, it lets you filter. And so I can filter by words in the commit, so like silly. And now the only word in a commit message that says silly is this one. You just hit Enter to filter. And you can also filter by branches. This is what I meant by closing branches. I can see that the only two open branches are default and my named branch. And so I can just only see what's in default or only see what's in my named branch. You can also search by tags, which are just a feature that lets you mark a specific change set with a tag, just like any other kind of site that uses tags. You can also use those change set hashes, and so I actually have it set up in perspective that anytime there's a build, that build knows what the HG hash of the revision it's in, which means that if someone has a bug, I can just look at it and it'll give me a hash like this, and I paste it, hit enter, and now I know which revision, and I know exactly what revision they had that problem in. And so yeah, and there's also these special filter commands. If you hit this ... you can look through them, but essentially they let you, so if I want to see all the heads, I can just do heads. There's also head, which is different. Okay, maybe it's just head. Yeah, yeah. Heads takes another set. It's kind of a little built-in language, so it's kind of complicated, but it's really useful. You can also do an interval of a date and that kind of thing. Okay, next is manifest view. I showed it a little bit before, but it's actually even more powerful. I didn't even find this out until a couple weeks ago, or about a month ago, I guess now. So it doesn't just let you see the state of any of the files at any change set. It lets you see what change set pushed any given line. And so I'm just gonna close this so you can see. So if I, yeah, I'm in here. So right now it's showing the differences of each commit. If you hit this button right here, view change in context of file, and so now it'll show it in the context of the file. So it's removing it's changing this line to something not sensible, but you can just see the entire file. But what's really cool is you can hit annotate with revision numbers, and I'm actually going to go into the Widdershins is the perspective team's repository, just so you can see. So also you can filter through the files. So this is the entire repository, but let's say I know I want to look at graphics context. And so there's graphics context. And so now it's just this is the file at this version. But if I do annotate with revision numbers, you can actually see over here, this is the revision number that each line was committed at. And you can see at the very bottom down here, you can actually see when whatever line you're hovered over, it shows who did it, what revision they did it at, how long ago was it, and the commit message. And so it's like, oh no, oh man, I know this line is what broke it, but I don't know when that happened or why. You just go into this view, hover over it, and you can see, oh, it was David, so I'm going to punch David. Especially now it says, oh, it compiles now to fix resources. Great commit message, and now I know that he just did something stupid that I can fix. So that's really useful, and I wish I knew about that a year ago. Okay, we are actually done. Yep. That's about it. So any questions? Yes, it only does save the deltas, which means that it's not. So if it's not going to save the entire file for every version, but it means that when you commit a large file, if you commit like a giant 1 gigabyte raw WAV file, and then you change it, it's going to commit the delta. So the entire file and then the entire delta of that file. So it is going to get big rather quick. If we look at real quick, you can actually go in here and right click any of these repositories. So like go to Widdershins Explore and it opens it up, which is useful. But it's all in this .hg folder. You'll notice that it's none of the subfolders have that .hg. It's just the one folder, unlike Subversion. So if I right-click that, properties, I have a bunch of resources in here, and we've been using this for about a year now, and it's only about 300 megabytes. So it's not that bad, but like for the raw audio files that we use with Wwise, which actually I might give a presentation on another time, because Wwise is awesome, but only supports uncompressed WAV files as your originals, that I actually have in a Subversion repository. There's also an extension for this over here. For Mercurial, there's an extension called large files. And that, from what I hear, I've only really read about it, I haven't actually used it. Essentially you can mark certain files as being large files, and then it'll act kind of like Subversion, where it will use Bitbucket as the repository, and any operations on those files have to go through it, and it'll only store it on the server. I'm not sure how well that works, and I've heard it's really buggy. It didn't actually go into Tortoise Workbench until very recently because it was so buggy. So use at your own risk, but that is a solution to that problem. Other questions?
Could you show creating a named branch and then closing that?
Sure. Yeah, so as you can see in Widdershins, we have just like tons and tons of commits, and a lot of them are in default. That's probably bad. You can also see as we go down, the number of simultaneous branches kind of goes crazy. This is because a lot of it is actually where we forgot to close them, and then once we actually close them, it just kind of propagated. So yeah, right here you can see we just closed a bunch of these at once that were actually from way farther back. But yeah, it kind of just goes crazy. Also, this is a virtualized list, so the more you pull back, it's not actually going to go to the bottom for a while. But you can also see that as it goes on, we kind of use more and more branches because we realized how cheap they are and how good it is to use them. Anyway, to show what you asked for. So right now I'm in my named branch, but and so I could actually close this branch, and it's like I'm done. Or actually, to show it in a more correct way. So the good way to always merge into default is to merge default into you, just like you do normally as you go. So just merge with local, select the head of default. There's a merge conflict. I'm just gonna to get over with. And so now default is merged into me. And then now that I know that that's all set up, or like it's all merged together and good, I can close this branch. This branch is done forever. You can actually reopen a closed branch, so don't think of it as something permanent. It's just that means that it's done. And now if I go back to default, I can merge this into default. And it even automatically says merge with my named branch. And to open a branch, you just like when closing, you just hit this branch button and then say open a new named branch, and that's it. Any other questions? All right, thanks.